All right, welcome back, ladies and gentlemen. This will be lecture number 3 on factoring polynomials, factoring the greatest common factor, or the GCF, out of polynomials. So, our objective for today is that we will factor out a GCF from a multi-term expression. Multi-term expression being a polynomial. Okay, and the essential question is, how do we factor out a GCF from a multi-term expression? So naturally, before we get into these objectives and essential questions, we need to do a little bit of defining. Okay, we have to define some things, probably things that you remember, but we'll take a look at it anyway. Okay, so let's take a look at the definition for a greatest common factor. Greatest common factor. Okay, greatest common factor is the greatest factor that divides two or more numbers. Okay? The greatest factor that divides two or more numbers. All right. Now let's go ahead and define factoring. Okay? And this is going to be in my own words to make it more understandable. But really, when I say factoring, I mean when you undistribute or remove the GCF from a multi-term expression. Okay, when you undistribute or remove the GCF from a multi-term expression. Now, this term factoring, or the action of factoring, we will redefine later on in Algebra 1. But for now, that's what we're going to call it. All right. So in order to understand what factoring is, when I say let's go ahead and factor something out of this expression, we need to first look at the reverse of factoring, or distribution. So let's take a look at this distribution problem. All right, and this time I'm going to show the intermediate step. Okay, so when we do this distribution, the rainbow or arrow method, we're going to do 5 times 3x, and that'll be minus 5 times 2. Okay, and this is the intermediate step. Okay, that's the intermediate step. All right, that's what most people won't show you the work for. So really what that comes out to when we multiply is you're going to get 15x minus 10. 15x minus 10. Okay? But factoring really is just going from this up to this. It's doing this whole process in reverse. Okay? So when we find our greatest common factor from this step, this 15x minus 10, you're going to get to this intermediate step where we've pulled that out. And then we can put it outside the parentheses to get to something like this. All right, so let's go ahead and take a look. We're going to look at this example here, this 36x plus 18. Okay, 36x plus 18. So what do y'all think the greatest common factor for 36 and 18 are? Or is? So first we're going to find the GCF. Okay, that's going to be the first step. And the greatest common factor between 36x and 18 is actually 6. So we're going to go from, remember, we're going from this to this now, because I want to be able to see the progress. So we're going to factor out a 6 from both of these terms. Okay, so I've got 6 times 6x, and if you multiply that out, you're going to get 36x. And I've got plus 6 times 3. So there's my greatest common factor, that 6 and that 6 out front. Okay, and what we know now, if you look at this intermediate step, if we go back a second, you look at this intermediate step, what we know is that we can go from this to this. We can just take this 5 and this 5 and put out front with some parentheses. Well, you can do the same thing down here. So let's do it. Let's just put the 6 out front with parentheses because it means the same thing, and then include this one and this one, 6x plus 3. There's the plus sign right there. Okay. And now we factored out the GCF, or that 6. And so this thing, this 36x plus 18, and this 6 times parentheses 6x plus 3, those are actually the same thing. Okay, they just look different, but mathematically they are equivalent to each other. Okay. All right, let's look at a couple more examples. Let's look at this negative 24x minus 40. Now the first thing I see here is that there's a lot of negative signs, okay, or minus signs. A lot of both of those. All right, so that's probably an indicator that my GCF is going to be negative. Okay, it's going to be a negative. So first thing, we're going to do the intermediate step. We're going to find the GCF. Okay, we're going to find that GCF. So what is the greatest common factor between negative 24 and negative 40? Now I want y'all to think about it. What is the biggest thing you can divide out of both of those? Once we've done our thinking, we've furrowed our brows, and we've thought about it, you'll find that the greatest common factor should be a negative 8. If you got 8, that's okay. What's inside the result will be that inside the parentheses you'll still have negative signs. But if you can factor out a negative, go ahead and do that. Okay, so let's see. Negative 8 times 3x is what's going to give me negative 24x, plus a negative 8 times 5. That's going to give me the negative 40. So we've found our greatest common factor, and now we're just going to take this guy and put it out front with some parentheses. So negative 8 parentheses 3x plus 5. Okay? And we have factored. Okay, so my step for that is just going to say factor out the negative 8. All right? Now, remember, this thing here and this thing here are equivalent. They're the same. Okay, they're exactly the same as each other. All right. Now, I want y'all to go ahead and pause the video on this next problem, this 50x minus 80y, and see if you can find the greatest common factor for that thing. Okay? All right, so now that you've paused the video and you've tried it yourself, let's take a look. Okay, I'm going to find the GCF for 50x and negative 80y. Okay, and the greatest common factor there is going to be 10. Okay, so you're going to have 10 times 5x minus 10 times 8y. Okay, and now that we have this greatest common factor, we're just going to take this thing, this 10, and pull it out front with some parentheses. So I'm going to factor out 10. Okay, so you're going to get 10 parentheses 5x minus, there's the minus sign right there, 8y. y. Okay? All right. So now we've done a few examples where we're just factoring out numbers. This is the time where I get to ask, can it only be a number out here? And of course, you know, when you ask things like that, you're going to get no. Of course it doesn't have to only be a number, Mr. Wilkie. All right, well, let's take a look. Let's ramp it up. All right, if we're really looking at this example here, this 13x cubed plus 7x squared, let's take a look at what that will look like when we expand those exponents. Okay, instead of using an exponent, let's expand that to what it truly means. All right, so I'm going to put expand. Okay, and we're going to expand that. So 13 times x, remember x cubed is just a way of saying x times x, or x times itself 3 times, right? And if we go ahead and expand the second term, you're going to get 7x times x, okay? When we look at this, we can see that we have 2 multiples of x's in both the first and second term. So now I'm going to pull these guys out front and make that my greatest common factor. Because they are factors, are they not? They are. Okay, so let's pull that out front. And we're going to get x squared. And then, so I've done this x times x is x squared times 13x. Okay, that's what's left over, 13 and x. Plus, and then x squared. Okay, there's my x squared. And then times 7. Okay, so that's me finding greatest common factor. Okay, because x's are factors, they are multiplied. So now we know we can just pull these guys out front with parentheses. So you're going to get x squared out front, and then inside, what's left over? 13x plus 7. Okay, so now I've factored out an x squared. That's a pretty complicated example if it's the first time you're seeing it. So let's go look at this example here where we've got no exponents, okay? 12x minus 15y, xy, sorry. Okay, so now I want to find the greatest common factor. So I'm going to find the greatest common factor for 12 and 15. Okay? But I want you to notice there is an x in both of these, and since factor is really things that are multiplied together, okay, those are factors to get you that term. Since there's an x in both of these, we'll be able to factor out an x as well. Okay, so let's find the GCF here. Let's find the GCF. Okay, what's the biggest thing, the biggest number I can divide both 12 and 15 by? Well, that's going to be, it's going to be 3. Okay, so I'm going to have 3. But remember, there's an x in both of these things as well. So I'm going to have 3x as my factor. Times, and then what's left over when you divide 3 out of this guy? It's going to be 4 minus, and then remember, the greatest common factor is 3x, so this will be times 5y. Okay? And now that I've found that greatest common factor, I'm just going to factor out, okay? Factor out the 3x. All right, and what that's going to look like is 3x outside the parentheses, 4 minus 5y inside the parentheses. Okay, so those are this term here, this 3x parentheses 4 minus 5y, and this 12x minus 15xy. Those are the same thing, they just look different. We've just altered the appearance, but mathematically, they are the same expressions. Okay. Now, we've done a lot of work with 2-term expressions. So let's take a look at something that doesn't have 3 terms. Don't freak out. It's the same exact process, except this time we have 3 things that we want to find factors for, okay, the GCF for. So let's find the GCF for this. Let's find the GCF. What is the biggest number that I can divide out of 15 and 40 and 35? Biggest number. After thinking for a minute, I know that number is 5. So let's find the GCF. We know it's 5, so we're going to end up with 5 times 3x would give me 15x, plus 5 times 8y would give me 40y, plus 5 times 7z would give me 35z. Okay? And now I'm just going to factor the 5 out. Okay? So we're going to take these 5s and factor them out, put them in front of parentheses. Okay, so you're going to get 5, parentheses, 3x plus 8y plus 7z, and there is your factored form. All right, great. So if you were taking notes, you should have been, but while you were taking notes, okay, let me make sure that you got everything you needed. So here is an example of my first page of notes. Go ahead and pause the video. You can zoom in if you need to. Okay. Here's the next page. Go ahead and pause the video if you need to. And that would be the last page. Have a good day.